Hi everyone, this is coming to you from Education for All. We are now looking at problem number 2 to prove the limits of the function 3x minus 1 as x tends to 2 is equals to 5. So let's see what we get out of this. Firstly, intuitively, what this problem is telling us, this function here, 3x minus 1, if you plug in 2 here, because x is approaching to 2, you get 3 times 2 minus 1, which is 6 minus 1. That gives you 5. So you get your limit as 5. That is what intuitively this problem is saying. Am I recording? Correct. But if you want to do it rigorously, it's telling us that no matter how small, by making this x, the absolute value of x minus 2, by making x minus 2 small enough, we can make 3x minus 1, this is minus 5 also small. No matter how small you make this, you can also make this as small as you want it to be. That is where the proof lies. And that is what we are going to prove. Is it bright or better this way? That is what we are going to prove rigorously. Now, what do we need? What do we need? We are given, according to the formula, yeah? We are given how to state the formula. Let me use blue marker, that might help. We are given delta greater than 0. This is given from the formula, delta greater than 0, epsilon greater than 0. And we need to find delta, we need to find some delta greater than 0, short that x minus 2, because we are using distances, so we like to put greater than 0 because we don't want a distance to be negative. So that's why this one is here, just to indicate we are using distances and the distance cannot be negative. Yeah, when you are taking measurements of a distance, you can't have minus, otherwise it doesn't make sense. Yeah, which implies that, I'll put it down here. This implies that the absolute value of 3x minus 1 minus 5 is less than epsilon. That is what we want. So, so now, you are given this. We want to find a value. You know, from the formula, from the proof of epsilon delta, definition of a limit. It starts by saying for all epsilon greater than 0, there is some delta greater than 0. So that statement tells you that epsilon is always given, even if it is not given to you directly, but you can easily find it. It is the delta that you need to work out for, which is not given. So that being the case, we now have this statement here, which we can use to find our delta. This thing here, function here, the absolute value is less than epsilon. So we can use epsilon because epsilon is given. That's what I just said. It's delta that is not given. Yeah. So because epsilon is given, we can use it to find delta. So now, if you expand this one, you'll get 3x minus 1 minus 5 less than epsilon. So this gives you 3x minus 6 less than epsilon. So I want to take the 3 out. So this will give you 3, and then you have 2. You have x minus, x minus 2 less than epsilon. So that means x minus 2 is less than, divided by 3, epsilon divided by 3. They look alike, epsilon, and although they face in opposite ways, but they look alike. So that is what we got for epsilon, for delta. So from this one here, we can now choose a value for delta. It is easy now to choose a value for delta because this equation here looks the same, this one. And here we know x, the absolute value of x minus 2 is less than delta. And we got something here, absolute value of x minus 2 is less than epsilon over 3. So you can see a relationship. Now we're going to start the proof. Because if we set delta to be epsilon over 3, the inequality, this inequality will hold. That inequality will be correct. So now the proof. Because this proof goes reverse way when you are proving epsilon delta definition of a limit. It goes reverse way, so sometimes it causes confusion. So now we prove. We let epsilon greater than 0 be given, and we let is it okay? Let epsilon greater than 0 just as a given. So now what do we have? We have stated that because of this function here is valid for this value because we are using inequalities. Yeah? And we have chosen our delta to be epsilon divided by 3. So we know it is positive. Then we assume that this is this. We assume now that we assume this now. We're assuming zero x minus 2 less than delta. So this implies that the absolute value of 3x plus, so 3x, yes, minus 1 minus 5 if we assume that one, then this implies that this one here is equals to absolute value of 3x minus 6. This is equals to 3 into x minus 2. Agree? But what is x minus 2? We know x minus 2, the absolute value of x minus 2 is epsilon divided by 3. Therefore, for this one here, this will give you 3 times epsilon divided by 3. So what do you get? You get epsilon. Do you see that? You get epsilon. So we have gotten our epsilon, we've gotten our delta. Therefore, for every delta greater than 0, there exists, therefore, for every epsilon greater than 0, there exists delta greater than 0, such that epsilon, this will cancel it, such that 3x minus 1 minus 5 exists. That's the end of the proof. That's the end of the proof. I've proven it. I hope this helps. Thank you for watching. Bye-bye. We shall do 2 more problems similar to these proofs, and then we'll move to something slightly different. We're going to use the epsilon definition to show that a sequence converges or diverges. So once we finish that one, then we'll jump over to analytic number theory. This is very interesting branch, mathematics. We shall solve 2 more problems similar to this, then another set of problems slightly different, then we'll move over to this topic. Then you can see how we relate real analysis, which is to analytic number theory. One is discrete, one is continuous. Real analysis, we're talking about continuous functions. So how we use the ideas, the formulas of continuous functions to solve problems involving discrete functions. Thank you for watching. Bye-bye.